Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method part 3. So here we are going to use a different method to solve variation of parameters. Okay, so let's get going. So we are given differential equation of order 2. Here, y double dash is nothing but y double dash y2 is nothing but d square y by dx square, that is double derivative of y with respect to x. Okay, and this is an equation in operator form of the first equation. Okay, both are same. Given differential equation, y double dash minus 2y dash plus 2y equal to e power x tan x, and also here y dash or y1 is nothing but derivative of y with respect to x. Now we can write y double dash as d square y by dx square minus 2 into write y dash as dy by dx plus 2y equal to e power x tan x. Now we can write d square y by dx square as capital D square y in operator form minus 2 into dy plus 2y equal to e power x tan x, since differential operator is d by dx, right? Now take y common from all the three terms of LHS, we'll get d square minus 2d plus 2 into y equal to e power x tan x. Consider it as equation number 1, or consider the first equation as equation 1 and this one as equation 2 for our convenience. Okay, and here this equation is in operator form. Say f of d into y equals to some r of x, where f of d equal to d square minus 2d plus 2 and r of x is e power x tan x. Now we'll find the general solution of 1 or 2 using the formula y equal to yc plus yp. Okay, first we'll find yc using auxiliary equation and later we'll find yp using the solution of yc. I mean not solution, using yc. Okay, we'll find yc using the auxiliary equation and later we'll find yp using yc. Let's see how to find yc and yp. First we'll begin with the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 2d plus 2, right? Let's replace differential operator d by m, so that we'll get f of m equal to m square minus 2m plus 2. Then the auxiliary equation becomes m square minus 2m plus 2 equals to 0. Now we need to find roots of this equation, so we'll use quadratic formula. M equal to minus b plus or minus square root of b square minus 4ac by 2a. Now just compare this equation with quadratic equation am square plus bm plus c equal to 0 and find a, b, c. A equal to 1, b equal to minus 2 and c equal to 2. Now substitute a, b, c values in the formula. We'll get m equal to minus of minus 2 plus or minus square root of minus 2 whole square minus 4 ac by 2a, which is equals to 2 plus or minus square root of minus 2 whole square is 4 minus 4 2s are 8 by 2 1s are 2. This is equals to 2 plus or minus square root of 4 minus 8 is minus 4 by 2. Now we can write minus 4 as minus 1 into 4 by 2. This equals to 2 plus or minus. Now we can split square root of minus 1 into 4 as square root of minus 1 into square root of 4. by 2. Since we know that square root of minus 1 is I and square root of 4 is 2, so we'll get 2 plus or minus I into 2 by 2. Now take 2 common from the two terms of numerator, we'll get 2 times 1 plus or minus I by 2. Here 2 gets cancelled and we'll get 1 plus or minus I. Therefore M equal to 1 plus or minus I is a pair of complex conjugate roots. Therefore the roots are complex conjugate. Okay. We know that when two roots are complex conjugates, say m equal to a plus or minus ib, then complementary function looks like e power ax into c1 cos bx plus c2 sin bx. Right? So let's write complementary function to our problem. Yc equals to, just compare 1 plus or minus I with a plus or minus ib, then for a equal to 1 and b equal to 1, we'll get yc equals to e power 1 into x into c1 cos bx plus c2 sin bx. Then yc equals to e power x into c1 cos x plus c2 sin x. Therefore yc equal to e power x into c1 cos x plus c2 sin x. Or yc equals to c1 e power x cos x plus c2 e power x sin x. Let yp equal to, now just replace c1 and c2 arbitrary constants by functions of x, a and b, or replace c1 and c2 parameters by functions of x, a and b, then we'll get yp equal to a e power x cos x plus b e power x sin x, where a and b are functions of x. And if you compare yc with c1u plus c2v or yp with au plus bv, we'll get u equal to e power x cos x and v equal to e power x sin x. So here we have to find a and b using formulae. A equal to integral minus v into r of x by uv1 minus vu1 into dx, and b equal to integral u into r of x by uv1 minus vu1 into dx. Here it is not necessary to write integral constants for a and b, okay, because already we are having c1 and c2 and yc, so it is not necessary to write integral constants in a and b. Okay, and if you observe, we are having uv1 minus vu1 in both the formulas, so let's begin with uv1 minus vu1 and later we'll go for a and b. Here v1 is nothing but derivative of v with respect to x, and u1 is nothing but derivative of u with respect to x, is equals to u e power x cos x into v1, which is nothing but derivative of v with respect to x, right, minus v into u dash. U dash is nothing but derivative of u with respect to x. is equals to e power x cos x into, let's apply uv whole dash formula, since we know that uv whole dash equals to u dash v minus v dash, plus v dash u. Consider e power x as u and sin x as v, e power x as u and cos x as v here. Okay, we'll get e power x whole dash or d by dx of e power x with respect to x into sin x plus e power x into d by dx of sin x with respect to x minus e power x sin x into derivative of e power x with respect to x into cos x plus e power x into derivative of cos x with respect to x. This is equals to e power x cos x into derivative of e power x with respect to x is e power x into sin x plus e power x into derivative of sin x with respect to x is cos x minus e power x sin x into derivative of e power x with respect to x is e power x cos x plus e power x into derivative of cos x with respect to x is minus sin x. This becomes e power x cos x into e power x sin x plus e power x cos x minus e power x sin x into e power x cos x plus into minus minus e power x sin x, which is equals to e power x into e power x is e power 2x or e power x whole square sin x cos x plus e power x into e power x whole square into cos x cos square x minus e power x into e power x whole square into sin x cos x minus into minus plus e power x into e power x whole square into sin x is sin square x. Here e power x whole square sin x cos x minus e power x whole square sin x cos x gets cancelled. This equals to e power x whole square is e power 2x, okay, into cos square x plus e power x whole square is e power 2x into sin square x, or we can write it as e power 2x sin square x plus e power 2x cos square x. Now take e power 2x common from the two terms, we'll get e power 2x times sin square x plus cos square x, since we know that sin square theta plus cos square theta equal to 1. So we'll replace sin square x plus cos square x by 1, we'll get e power 2x into 1, which is equals to e power 2x. Therefore, uv1 minus vu1 equal to e power 2x. Okay. Now let's find a using formula integral minus v into r of x by uv1 minus vu1 into dx. This is equals to integral minus v. V is e power x sin x into u e power x tan x by uv1 minus vu1 is e power 2x into dx. This is equals to minus integral e power x into e power x is e power x whole square, or just add the powers, we'll get e power 2x. Okay, can just write directly e power 2x here, since e power x into e power x is e power 2x into sin x into tan x by e power 2x dx. Here e power 2x gets cancelled. This is equals to minus integral sin x tan x dx. This becomes minus integral sin x into, just replace tan x by sin x by cos x. Since tan theta equal to sin theta by cos theta. Right? Then this becomes minus integral sin x into sin x is sin square x by cos x into dx. Since we know that sin square theta plus cos square theta equal to 1, then sin square theta equal to 1 minus cos square theta. So let's replace sin square x with 1 minus cos square x. We'll get a equal to minus integral of 1 minus cos square x by cos x into dx. So in the numerator we are having two terms and in the denominator we are having one term. So we'll split this whole expression into two terms. This is equals to minus integral of 1 by cos x minus cos square x by cos x into dx. Right? Since reciprocal of cos theta is secant theta, so we'll replace reciprocal of cos x with secant x. And here you can write cos square x as cos x into cos x. So cos x into cos x by cos x is cos x. Right? So if one cos x gets cancelled from the numerator and denominator, we'll get cos x, which is equals to minus integral secant x dx plus integral cos x dx. Since we know that integral secant theta d theta equal to log mod secant theta plus tan theta, and integral cos theta d theta equal to sin theta. So we'll get minus log mod secant x plus tan x plus sin x, okay, which is our required a. Therefore a equal to minus log mod secant x plus tan x plus sin x. Let's now find b. We'll find b using u into r of x by u v1 minus v1 into dx. This is equals to u e power x cos x into r of x is e power x tan x by e power 2x into dx. This is equals to e power x into e power x is e power 2x into cos x tan x by e power 2x dx. Here e power 2x gets cancelled. This is equals to cos x into tan x dx. This is equals to integral cos x. We can write tan x as sin x by cos x, since tan theta equals to sin theta by cos theta. Here cos x gets cancelled and we'll get integral sin x dx. Since we know that integral sin theta d theta equal to minus cos theta, so you'll get minus cos x. Therefore b equal to minus cos x. So we got a and b. Let's now find yp. We have yp equal to a e power x cos x plus b e power x sin x, right? Let's replace a and b here. Then yp equal to a minus log mod secant x plus tan x plus sin x into e power x cos x plus b minus cos x into e power x sin x. From this we'll get yp equal to minus e power x cos x log mod secant x plus tan x plus sin x into e power x cos x is e power x sin x cos x plus into minus minus cos x into e power x sin x is e power x sin x cos x. So here plus e power x sin x cos x and minus e power x cos x, minus e power x sin x cos x gets cancelled. This equals to minus e power x cos x into log mod secant x plus tan x. So we got yp and already we have yc, so let's write the general solution using y equal to yc plus yp. Therefore, the general solution of given equations or 1 and 2, 1 or 2, whatever, is given by y equal to yc plus yp. Okay, y equal to yc, we are having e power x into c1 cos x plus c2 sin x, and yp is minus e power x cos x log mod secant x plus tan x. This completes the problem. So we have seen a problem using variation of parameters in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.